Hello, good day, good afternoon, good morning, good evening, wherever you are watching from. I hope you are having a great day so far. For those of you who do not know me, I am Dr. Nandi. I frequently go live on YouTube on my channel, and I also have recorded a large number of videos on solving math problems. I have also some fun videos on my channel. So when you get a chance, please check out my channel. And if you like my video, please give me a thumbs up. That really motivates me to produce more interesting videos. And if you like the videos, subscribe to my channel. So without further ado, we will get started. Today we are going to work on a problem on hypothesis testing in statistics. I know a lot of you think that statistics is very difficult. I will try to break it down, the steps in the problem easily so that you can follow the easy steps and solve the problem. I will also be using a formula and everything. So let's get started. I will share my computer screen with you. – 7% of Americans do not use internet. Suppose this study is based on a representative sample of 600 adults. Does this support the claim that the proportion of all Americans who do not use the internet is less than 10%? Use a level of significance of 0.05. So, what is the claim? The claim is always usually the alternate hypothesis that the population proportion of people who do not use internet is less than 10%. We will convert 10% to decimal 0.1. This is your claim. And the opposite of this, or the status quo, is the null hypothesis, is p equal to 0.1. Most of the time, the null hypothesis always contain the equal to sign. And the claim is the proportion, p is the population proportion of people who do not use the internet is less than zero point 0.1. Okay. So hypothesis testing, they go in pairs. We have also a statement in the beginning of the problem says 7% of Americans do not use internet. Suppose this study is based on a representative of 600 adults. So the sample that they studied before making this claim. So the sample size n is 600. And if you take x as the number, or not x, let me clear that. So give me a minute, I will clear it. So sample proportion, so people who do not use on this in the internet based on this sample is 0.07. 7% in decimal is 0.07. So p hat, so I'll come over here. P hat is the sample, so this is to be read as p hat. Okay, sample proportion of success, or proportion of people who do not use internet, is internet, and that p hat value is given as, I'll write it over here, so write it over here, p hat is given as 7%, in decimal is 0.07. So we will use the sample data, compare the sample proportion to the population proportion, hypothesized population proportion, or the value in the null hypothesis. Compare the sample proportion of 0.07 to the value in the null hypothesis, which is zero point 0.1. And we can do that easily by calculating the standard score for p hat. Okay, compare p hat to the value in the null hypothesis. P hat is the sample proportion 0.01. Compare that to p, which is zero point 0.1. We convert that to a standardized test score, or z. Okay, so before we do that, we need to check out. So need to check the value, check the value of n times p, which is n is your 600, p is the value in the null hypothesis, is 0 0.1. So 600 times 0 0.1 is equal to this. So 600 times 0 0.1 is equal to 60. That is, has to be greater than 100. What is n times p? N times p is the population number of success, assuming the value in the null hypothesis, which is zero point 0.1. We also need to calculate the value of n times 1 minus p, or 600 multiplied by 1 minus 0 0.1, which is 600 multiplied by 0 0.9, and that is equal to 540. That is also greater than 10. This is not 100, this is 10. It has to be greater than 10. So both of them, n times p, number of success in the population using the value in the null hypothesis, n times p should be greater than 10, and n times 1 minus p, which is the number of failures, that should be greater than 10. So these conditions have to be met, and the reason is, I will write it down in a minute. Since np and n times 1 minus p are both greater than 10, we can assume that the sampling distribution of p hat, which is the sample proportion p hat, is normal. This is essential. We need to check this out before we calculate the standardized test score, or standardized test statistic for the sample that we have collected. We need to check beforehand n times p and n times 1 minus p. Remember, p is the value in the null hypothesis, population proportion of success. Okay, and n times p and n times 1 minus p both should be greater than 10, which is true in our case. In that case, the sampling distribution of p hat is normal. Okay, so let's calculate the test statistic. Remember, I said we will compare is z. We will compare p hat to p. But not only that, we will divide it by the standard deviation of the sampling distribution. Okay. So let me move this up a little bit. Okay, so let me make sure I'm doing it correctly. So p hat is 0.07 as is given in the problem, right? So let me make sure that is the case. P hat is 0.07. Okay, so 0.07 minus zero point 0.1 divided by second x square, second x square is okay, so it is point, okay, second x square is square root, and it is 0.07 times 1 minus 0.07 divided by sample size of 600, and that is equal to point, so let me clear that. 0.07 minus zero point 0.1 divided by second x square, 0.07 left parenthesis 1 minus 0.07 divided by 600, and that is equal to negative 2.8. So is that right? Is that test one prophecy test? X P0 is zero point 0.1, 0.07 is 42, and 600 less than P0. Calculate 449. So this formula has to be corrected a little bit. So let's go this. Let's remove this. So it is divided by the standard deviation of the sampling distribution of p hat, and that is assuming the value in the null hypothesis. So this is in the denominator. We are going to divide by square root of p times 1 minus p over n. So this whole thing is the standard deviation of the sampling distribution, of the sampling distribution, of the sampling distribution. So that being the case, let's calculate it. We already have a value for p hat, which is 0.07. So if I move this a slightly bit up, oops. So Z is equal to Z is equal to P hat minus P is P hat is 0.07. Remember, P is the population proportion value in the null hypothesis, which is zero point 0.1 divided by square root of zero point 0.1 times 1 minus zero point 0.1. Whole thing is divided by sample size of 600, divided by, sorry, divided by, divided by n is 600, and that is equal to, so let's do the calculation. In the numerator, left parenthesis, 0.07 minus zero point 0.1 divided by second x square gives me the square root of zero point 0.1 left parenthesis 1 minus zero point 0.1 divided by 600, and the answer is minus 2 point, so this is minus 2.449. Now I'll change the color of the ink and draw a picture of the standard normal curve. So, okay, so let's draw the standard normal curve, that is the Z curve. Okay, So this is the standard normal curve. Center is z is equal to 0. And we have calculated a test statistic of minus 2.449 in the left tail. So let us calculate the probability of getting a test statistic, that is the z score, okay, of at least minus 2.449. This is nothing but area under the z curve to the left of minus 2.449. Notice the statement is at least as extreme. That means the minimum value is minus 2.449. It can be, or in this case, the maximum value is minus 2.449, and you can be further negative. So basically, if I come over here, I want to find the area under the standard normal curve. This is the area that is I want to find out, because any value to the left of minus 2.449 is more extreme than it. Okay, and this is the z curve. The center is 0, as I pointed out, because for this curve mu is 0 and sigma is 1. This is the z curve. Okay, so what is the value? So for that, I will use my calculator. So probability of z less equal to minus 2.449, which is same as area under the z curve to the left of minus 2.449. And that is equal to, I will use my TI-84. So what will I do? I will press the second button in my calculator, then the worst button, which is in the third row. Then I will go to number 2, which is normal CDF. So I'm going to find the area to the left of minus 2.449. So if I do a little bit of correction, I don't want to confuse this with this. Okay, the center is, of course, z is equal to 0. Okay, so to erase this. Okay. Okay. So here, this is the 0 point. This is z is equal to 0. The center negative is on the left, positive on the right. So no, so here I go on second button, then the worst button in the third row, then number 2, normal CDF. Okay, so my lower is already set up as minus 1 E99, which is fine. What is minus 1 E99? Just if I can represent in this diagram, this curve stretches to infinity, right? So it does not, of course, go up. Let me correct that. So it stretches to negative infinity. So if I go back here, it stretches, it comes very close and oh, it does not go below, so that's also incorrect. It Basically, it stretches to infinity. So if I erase that and go here, it is stretching. It comes close to the z-axis, but never really touches. So it ends at minus 1e99. What does it mean? It's lower is minus 1e99. That means, what does it mean? It's minus, then 1, followed by 99 zeros. E stands for exponents, 10 to the power of 99. But there is negative, so it's on the left. What is my upper? The next is upper, right? Upper is the upper boundary, and that is minus 2.449. Remember, for the upper, minus is next to the enter on the left, bottom right, rather. Bottom right, minus, okay? 2.449. Why am I pointing that? Do not use the minus on top of the plus. Mean is 0, standard deviation is 1. We are not going to change those. So mean is 0, sigma is 1, and I will go on paste and hit enter and enter twice. On paste, enter twice. Okay. So if I may move up now. So enter and enter. And so what do I find from my calculator? I find that probability of z less equal to minus 2.449 is 0.007. Very low probability. That means the chance of getting a test statistic at least as extreme, that is minus 2.449 or anything below that, minus 2.5, minus 2.6, is very low. Why that is the case? That is the case because most probably the value assumed in the null hypothesis is not correct. Okay. So we are going to reject the null hypothesis. There is another argument to this. Notice the level of significance in this problem. Level of significance is 0.05. What does that mean? That means we take a 5% risk. We take a 5% risk or probability. Risk in this case means probability of rejecting 80 when it is true. When it is true. This is the probability of making type 1 error. Probability of making a type 1 error. Of making a type 1 error. Or making a wrong decision. Now, I forgot to tell you, probability to the left of that calculated test statistic is also known as p-value. Now, if we compare the p-value with the level of significance, okay, so level of significance is given as alpha. Level of significance, which is the maximum probability of making type 1 error, level of significance is alpha, is given as 0.05. Our p-value is 0.007. Notice the probability of getting a test statistic at least as extreme is even less than alpha. So we can write p is less than alpha. Alpha is the maximum risk we are willing to take. And the probability value is much less than that. So decision in this case reject H0. And the conclusion is, if we reject H0, then we state at alpha equal to 0.05, there is enough evidence to support HA. Evidence to support HA. So basically, we are making this decision based on one sample, and the test statistic or the characteristic of the sample when compared to the value in the null hypothesis is minus 2.443, and the probability of getting that test statistic or something below it is very small, less than alpha. So we reject the null hypothesis and we support HA. What is HA? It states P is less than zero point 0.1. Okay, let's make sure I wrote it correctly. So, yeah, okay. And that is the claim. Okay, so got it? Let me summarize what I did. I took the test, not the test, let's start from the beginning. So, first, we wrote the null and the alternate. The claim is less than 0.1. That is a left tail test, as you will realize, because the test statistic, as you saw later, falls in the left tail. Anyways, so that is the alternate hypothesis. The null hypothesis always contains the equal to sign. We have given sample data, n is 600, sample proportion is 0.07. So we are going to calculate n times p. P is the value in the null hypothesis that has to be greater than 10, and n times 1 minus p also have to be greater than 10. Once we verified those, then we calculate a test statistic. What is a test statistic? As you can see from the equation, we are comparing the sample proportion to the value in the null hypothesis, p hat minus p, but we have to divide it by the standard deviation of the sampling distribution. And that is this formula. When we calculate the test statistic, it is minus 2.449. It's on the left of 0. Now we want to calculate the p-value, the probability value of obtaining a test statistic which is at least as extreme as minus 2.449 or more extreme. That means farther on the left tail. And that probability using second verse 2 came out as 0.007. That is the area in the left tail to the left of minus 2.449. Now that p-value, probability value, is even less than the level of significance given in this problem, which is 5%. What is level of significance, you ask? It is the maximum risk or probability we are taking in rejecting H0 when it is true. That is making a wrong decision, type 1 error. So P is less than alpha, decision is reject H0. If we reject H0, then automatically we state at alpha equal to 0.05, there is enough evidence to support the HA, which is P less than 0.1. I'm going to stop here today. If you have any question, comment, please do not hesitate to write me a small note. I'll respond to each and one of your inquiry or comment, I promise. So if you like this video, please give me thumbs up. That really motivates me. And please let me know where you are watching my video from. That is very important to me. And if you like this video, share with your friends. If you like this video, please subscribe to my channel by hitting the red subscribe button at that time. Do not forget to click on the notify button. And please do not forget to check me out tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day. See you.